Good afternoon. In the previous video, I received the comment from one of my famous followers and student, and he said that why can't we solve out a number that can come out than saying if they are equal, we do like this. Then I came up with just equations. These are two equations of lines, and this is line 1, this is line 2, which are in Cartesian equation. And I said when they are in Cartesian equation, you change them to vector equation. Before you changing the Cartesians, you have to be conscious about the values of x, y, and z. If one of these one is not a starting value, like you see x, this is x minus 0, this is the same as x minus 0 over 1. Then we have y plus 2. You see that z is the starting value and it is positive, as you saw also here. Now you can go ahead and say that your R1 will be equaling to, you open the bracket, you write off these values. When you negate them, you put them in negatives. Now this will be 0, this one become a negative 2, and this one will become a 5. Then plus any parameter you want, you can choose mu, then you take off these ones as they are, 1 to negative 1. Then from there you go to the next equation, where you will say that R2 will be the same as, you first look at them, are they positive and are they starting values? Yes. Then you pick off these other values when they are negative. The negative of negative 1 is 1, this is negative 3, this is 4, then plus lambda into negative 1, negative 3, and 1. Negative 1, negative 3, and 1. Now we have obtained the vector equations. Now what we need to do is now making the big bracket, as we said. Now to go for the big bracket here, we shall say that R1 will be equaling to a 0 plus mu, then negative 2 plus 2 mu, then a 5 minus mu. Then R2 will be equaling to, we'll do the same, which is a 1 minus lambda, then minus 3 minus 3 lambda, then a 4 plus lambda, just like that. And if we have that, we have a very good way to go. For point of intersection, they are equal. At point of intersection, R1 is equaling to R2 at the point of intersection. R1 is the same as R2. Equate this and this. It will have a mu, negative 2 plus 2 mu, then 5 minus mu. This is equaling to 1 minus lambda, minus 3 minus 3 lambda, then 4 plus lambda, just like this. This one is equal to that. This next one, they are equal, and also this one, they are equal. This one is for proving, this one is for solving to get the values of mu and lambda respectively. The equation I've represented here, they are these equations which we generated from the first values, and these ones we generated them from exactly from this point. Now when we go ahead formulating, then we will see that we shall have mu, we shall have that the mu will be equaling to this one, that mu will be equaling to a 1 minus lambda. Take lambda this side, meaning the mu plus lambda will be equaling to 1. That is equation 1. Then we go to the next one, a minus 2 plus 2 mu will be equaling to minus 3, then minus 3 lambda. Take this one this side and the constant the other side, so that we have a 2 mu plus 3 lambda will be minus 3 plus 2. Because this is negative, going the other side it becomes a positive, and this is negative, then coming this side it becomes a positive. Those are the origin of those positive value which you are seeing there. Now I can have a 2 mu plus 3 lambda. This is equaling to negative 1. Now this is equation 2. Now I want to solve equation 1 and equation 2 simultaneously, so that I get the values of mu and the lambda. Then mu plus lambda is 1, depending on the math you know of solving two simultaneous equation. Then you'll be getting the values. Then for me, I'm going to multiply mu and subtract. If I multiply and subtract, I'll get a 0. multiply and subtract. Here I'll be getting a minus lambda, then here I'll be having is 3, then lambda will be a minus 3. Then I can go ahead and get a mu, because I saw that a mu plus lambda would be a 1. If lambda is 3, then a mu plus minus 3 will be a 1. Then mu will be equal to the negative become a positive, will be equal to a 4. Then I'll go to the one of checking. Remember, we have the one of we check whether the thing is right, and in the check one we had that the one which we said we had to use it for checking is this one, that 5 minus mu will be equaling to a 4 plus mu. Substitute in mu and lambda values. We have seen that lambda is a minus, a mu is a negative 4, mu is 4. If you see here, lambda is negative 3 and mu is 4. Now we shall have 5 minus 4. This is equaling to a 4 plus mu, which is minus 3. Now 5 minus 3, that is a 1. This is equal to 4 minus 3, 1. Now we have both, they are the same, 1 1. Now if we achieve 1 1, we say now those, if they say prove that those ones intersect, you say hence the line is what? The line is intersect. Then find the point of intersection. You choose, you know that mu is equaling to 4 and lambda is equaling to a minus 3. Then you choose one of the two lines. Remember, we have our lines in this format, and we have seen that our line 1 it is here. Our line 1 was equaling to 0 plus mu, then minus 2 plus 2 mu, and a 5 minus mu. I can go to this one and substitute in the value of mu, and we have seen that the value of mu is 4. Then I can say this is 4. Then we know it will be a negative 2 plus 2 into a 4. Then this will be a 5 minus 4. Then R1 will be equaling to a 4. This will be 8, 6, and this one will be 1. And this is a vector. Then if they want it in Cartesian, you say R1 will be a 4, 6, and 1, just like that. And this one will qualify to be our point of intersection. Or else some of you will say, now for me I want to use the other R2. It is also okay. It has no problem. You will say that R2 is equaling to 1 minus lambda minus 3 minus 3 lambda, then a 4 plus lambda. Don't forget that our lambda is negative what? Negative 3. Substitute R2 will be equaling to 1 minus negative 3, then a minus 3 into negative 3, then a 4 plus a negative 3. Negative is a positive. R2 will be equaling to a 4. Now this will be a negative 3 times negative 3, negative 9 minus 3, that is a 6. Now a 4 minus a 3, which will be a 1, and this is our the vector form. And in a Cartesian form, it is this one. This is the vector form, and this is the Cartesian form. And if you look at both equations, you will witness that both are the same. If they are in a vector equation, R1 is here and R2 is here. You will see that they are equal. Now it doesn't depend on what you use and what you leave out. Now let's go ahead. I hope now my students are now following and things are moving now well. You are going to try out. I'm going to send some. I'm going to be sharing numbers. I will share in your respective WhatsApp groups and respective channels of YouTube you are using, and we shall be seeing how we can go about them. Don't forget to subscribe so that you get informed about any video that I'll be shooting and the one I'll be uploading. Okay, we meet in point of intersection. This point of intersection, now we meet for the angle, and we move on.